Okay, illustrative math, unit 2, lesson 26 is called using the sum. This is kind of like the same thing that we did yesterday. So I think my Bitmoji is kind of appropriate, or the same thing we did in lesson 2.25, I should say. All right, so our goal is I can use the geometric sum formula to solve problems. If you need a refresher on what the geometric sum formula is, it's S for sum equals A times 1 minus r to the n over 1 minus r. S is your sum, total sum. A is the initial value. Just say initial amount. R is your growth factor or growth rate, the number you're multiplying by. N is the number of terms that you're finding the sum of. Okay, so it has to be a geometric sequence. So it'd have to be like, something like this: 2, 8, 32, so forth. So A would be 2, R would be 4 in this case. So let's say I wanted to find the sum of the first, 20 terms, N would be 20 or whatever. All right. So it depends, whatever you want there. But there you go. There's your formula. All right. So warm up. Recall that for any geometric sequence starting at A with a common ratio R, the sum S of the first n terms. So we just went over that. So find the sum of the approximate 50 terms. So that's going to be n equals 50. This is going to be A. And what do I multiply 1/2 by to get 1/4? Now, if you can't do the math in your head, just make an equation. 1/2 times x equals 1/4. We'll just use a little algebra here, and we get x equals 1/2. Okay, so r is 1/2 as well. Maybe I should have used r instead of x. Maybe that would have been a little bit more appropriate. 1/2 times your common ratio. All right, so let's use the formula. So the initial value is 1/2 times 1 minus 1/2. Whoops. Should not have put the 1/2 to the 50th over 1 minus 1/2. Now you gotta be careful with your calculator here. Make sure you type it in correctly. It's not a bad idea to use a decimal if it's an exact fraction. So let's see here. I'm going to type it in here. 1/2 times parentheses 1 minus 1/2 to the 50th divided by 1 minus 1/2. So make sure you put that whole 1 minus 1/2 in parentheses. And I get 1. All right, so this would be 1. All right. Next one, this is going to be A right here, my 1, my initial value, 1 times 1/2, so my common ratio is 1/2, and n is still 50. Go ahead, plug it in. 1 times 1 minus 1/2 to the 50th divided by 1 minus 1/2. And you should end up getting 2. All right, so a little review of the formula from yesterday. All right, so now we're going to maybe kind of use the same type of formula, but we're going to maybe put it into context. So in 2012, about 71,000 homes were sold in the United Kingdom. For the next 3 years, the number of homes sold increased by 18% annually. So 18% increase each year. So you're really going to multiply by 1.18 is what that means. All right, assuming the sale trend continues. How many homes were sold in 2013 and 2014? So I got 71,000 times that by 1.18, and that will give me the next number. So 71 times 1.18, I get 83.78. And then I do the same thing times 1.18. And I get 98.8604. So my answer here would be 83.78 thousand. And that's 2013. 2014, 98.8, whoops, 8604 thousand. Okay, so what information does the value of this expression tell us? Well, this is my initial value in 2012. This is my rate, and this is the number of terms. So that would be the sum of, but the total sum of all houses sold in the United Kingdom from 2012. So if we're going for 11 years, that would go until 2023. Okay, so 11 years. So it's going to give us the total sum, not just the 11th term, the 11th term plus the 12th term plus the 11th term plus the 10th term plus the 9th term, all the way down to the very first term. It's going to add them all together. All right, predict the total number of house sales from 2012 to 2017. Explain your reasoning. So the key word there is the total right here. Whoops, total number. So we got to sum them all up. So our initial value is still 71. 1 minus 1.18. So my power now is going to be 5. 1 minus 1.18. And then the key here is just make sure you type it into your calculator properly. If you use the fraction button, if you got a TI-84, you can hit math, and then go over to fraction. And there should be a button there to type it in without using the parentheses. That's what most people screw up, is the parentheses. But go ahead and type that into your calculator, and we should get 670.4 thousand. Okay. Last question. Do these predictions seem reasonable? Explain your reasoning. So, I mean, it seems like it would be hard to keep that level of growth forever. Okay. Like eventually you're selling 670,000 houses total in 5 years. Eventually it's your graph is doing this. It's exponentially growing, and eventually it's going to have to flip and invert and level off eventually in reality, because you're going to run out of people. You don't have infinite people. I know the y-axis goes infinitely, but if it's people, you're not going to have a need for as many houses. So that's what I would say for that. All right, on to the next one. Let's say you open a savings account with an interest rate of 5% per year compounded annually. So that means they give you your money once a year at the end of the year. And that you plan on contributing the same amount to it at the start of every year. Predict how much you need to put into the account at the start of each year to have over $100,000 in it when you turn 70. So I guess part of the problem is they don't give you a starting age. So I guess we'll just use a random age of a high school kid. We'll just say 18 years old. Okay, so that's a little bit of a problem here. So let's just say you are 18 years old now. Okay, so predict how much you need to put in the account at the start of each year to have over 100,000 when you turn 70. So let's start figuring out some things here. So you got your formula: S equals A times 1 minus r to the n over 1 minus r. So we know that our growth rate is 1.05 because you're increasing at a rate of 5%. So your initial amount, so we're going to kind of trial and error that. So A, we're not really sure what we're going to have to put in. And we know N is going to be, what's 70 minus 18? That would be 52. So I'm going to just try some random numbers. I don't know. I got to get 100,000 in, but you're going to do it for 52 years. So I don't know. I'm going to just start out with $500. If I plugged in 500 times 1 minus r, I'm sorry, I shouldn't say r, 1 minus 1.05 to the 52 power divided by 1 minus 1.05. And let's just see what that gets, okay? And we'll just, try to figure it out from there. So that gives me actually more than I need. That would give me 116,428. So it's probably going to be less than 500. So, if you want to trial and error a few more numbers till you get it, that would work. But what you could do here is, if I did this, if I plugged in 100,000 for S and solve for A, I think I could do that. I'd have 1 minus 1.05 to the 52 divided by 1 minus 1.05. So if I multiply each side by 1 minus 1.05, I could now cancel these, and let's do this math here. 1 minus 1.05 times 100,000 gives me negative 5,000 equals A times, I'm just going to leave this because it's probably going to be a long decimal number because it's to the 52nd power. So if I just divide by this, that should give me the actual exact amount. So I'm going to make sure you put in parentheses in your calculator when you divide by 1 minus 1.05 to the 52 so that it does it properly. And I got 429. I'm going to round it to 2 decimals because it's money. So that's how much you have to put in at the beginning of every year to have $100,000 when you turn 70. Not too bad, because if you think about it, if you multiply this by 52, you really only actually contributed $22,331, and you got 100,000. So most of that was all interest. Calculate how much the account would have after the deposit at the start of the 50th year if the amount invested each year were 100, 500. So I'm gonna just plug everything into the formula. The only thing is these are going to be A. I'm just going to have different A values. Oh, sweet. I did the 500 actually already. 500 was 116,428. So if I go ahead and plug those in, I'll get you those values. So 100 times 1 minus 1.05 to the 52 divided by 1 minus 1.05. So to put $100 in per year, it would be 23,285. If I put, let's see here, if I change it to 1,000, you'd have 232,856. And if I changed it to 2,000, I'd have $465,712. So kind of crazy how much money you could have if you just put a little bit away each year. Oh shoot, you know what? I did to the 52nd year. Whoops. I did the 52nd year. I'm not going to change it. I'm not going to go back and redo them. But to the 52nd year, it would be this amount. All right, number 3. Say you decide to invest $1,000 into the account at the start of each year at the same interest rate. How many years until the account reaches $100,000? How does the amount you invest into the account compare to the amount of interest earned by the account? So let's take a look at this one here. So we want it to equal 100,000. So that's my S. My A is 1,000. We have the 1 minus 1.05. This time we don't know how long, so my N is going to go up there. And then it's 1 minus 1.05. So we got to do a little bit of work here. How does the amount let's see here. How many years until the account reaches 100? So I got to kind of do a little algebra here. End up with negative 5,000 equals 1,000 times 1 minus 1.05 to the n. Divide by 1,000. I get negative 5. I can minus 1. Negative 6 equals 1.05 to the n. Okay, so you haven't learned how to... Oh, I forgot my negative. Actually, I could divide by a negative 1, because really it's negative 1 times 1.05. And I get here. Okay, so you haven't really learned how to do this yet. So right now, I'm just going to trial and error it. So 1.05, I'm just going to take it to different powers. I'm going to say to the 30th. And that gave me 4.32 if I plugged in 30 for n. So I got to get bigger. 1.05 to the 35th. And that gives me 5.5. So I'll try to the 36, closer. 37, about 37, okay? So take you 37 years to get there, okay? Okay, so the next question is, how does the amount you invest into the account compare to the amount of interest earned by the account? So, if you think about this here, you basically, for 37 years, you ended up putting $1,000 per year. So you only actually invested 37,000, but you ended up having 100,000. So this is what you invested, and you actually have 100,000. So 100,000 minus 37,000 means you have 63,000 in interest. So obviously the interest is greater, much greater, which unfortunately you have to pay taxes on that because they treat it like it's earned income, even though you didn't actually go to work to earn it. You earned the money through your good decision making and in deciding to invest. All right. Interest is much greater than the invested amount. All right. On to the next one. All right. So if someone asks you to explain how to find the sum of the first n terms of a geometric sequence, how would you explain them? I would say, well, you better know the formula. And I would say A is the initial value. R is your growth rate or growth factor, I guess. N is the number of terms. And the keyword there is sum. This only finds the sum of those terms. All right, so I can use geometric sum formula to solve problems. I think so. Last one here. Lynn wonders how much money she could save over 30 years if she puts $100 at the start of each year into an account with 3% interest per year compounding annually at the end of the year. She calculates the following, but thinks she must have done something wrong since that seems like a lot of money. What did Lynn forget to do in her calculation? How much should the total be? So I think the key is right here. She did 30%. It should be 100 times 1 minus 1.03 to the 30th divided by 1 minus 1.03. So I would say there that she plugged in a interest rate of 30% instead of 3%. So I'm going to type into my calculator here and calculate it. And here's what I got. I got 475754. So again, I always like to compare it to how much she actually invested. She invested $100 per year for 30, not 300 years, 30 years. So she actually only invested 3,000 and looks like she made 1757.54 in interest. That's interest, and this is invested. Okay, so looks like didn't make as much money as the last problem, but then again, her rate was much lower. So, all right, hope you enjoyed this lesson. Thanks for watching.